May 2018, question 2B. It is on Anova and coefficients tables. Anova and coefficients tables. So the question says that the following data relates to the weekly amount spent on entertainment by households, the annual income of the head of the household, and the household size in terms of number of persons. We have amount spent per week, annual income of the head of household per year, household size. The complete output of the above data using a spreadsheet package was provided as follows. So we have the regression statistics. We have the observations, rather the Anova table, and the coefficients. So you are told to do the regression of the data. Just a minute. So we are told to evaluate the one. We are told to come up with the regression equation. And before we come up with the regression equation, it is good to come up or to identify who are the variables. Who are the variables in our table. And when you identify the variables, there are two types of variables. There is what we call the dependent. The dependent, which is represented by Y. In this question, the dependent, we are told that the following data relate to the weekly amount spent on entertainment by households, the annual income of the head of the household, and the household size in terms of the number of persons. So what is being mentioned here is the amount spent per week. That is what we want to study. The amount spent per week. Spent per week by a household. The amount spent per week, obviously on entertainment, per household. Then we have those which we call the independent. And in this question, there are two independent. So there is X1, and the first independent variable is annual income. It's the annual income per household. The annual income per household. The second one, X2, because there are two, is household size. Is household size. So once you have known how many variables are present in your question, the next thing that should quickly come to your mind is the format of the equation. So this tells you you are going to have an equation of y is equals to a plus b1 x1 plus b2 x2. That is the kind of an equation that we are going to have. And something else that you should quickly identify based on this is what we call K. K refers to the number of the computed variables. The number of the computed variables. So the computed variables, you count, in other words, let me put it in a very simple way. It is the items that are in this format which are not here. So the ones which are not there, it is 1, 2, 3. They are the ones that we shall compute. Yeah. Then from there, you get the equation. You get the equation. Now the equation is obtained from the table of coefficients. You can see we are given the Anova, the first table there, which the first column is labeled Anova. Then there is another one, which is the first column does not have a title, but the second item is coefficients. Now, in those coefficients, the first one is intercept. So intercept is the value of A. So you are supposed to say Y is equal to minus 4.099268. Then the value of B1 plus, that is 0.985761 x1 plus 1.762415 x2. So that is the equation that has been given. So once you have it that way, the next thing now is to do the reliability tests. And the reliability tests, they are usually divided into 3. So one, it is what we call economic plausibility test. Now this question in part 2 is saying we do a statistical analysis of the computer results. So that is what I have called the reliability tests. Again, I need also to mention that in an exam, the examiner had already asked for this equation, right? So you don't have to write these things, but they must be in your head because they are the ones that have generated this one. You must know them so that you do A equal happy, B1 happy, B2 the need. Yeah. But if you wrote this way, that would be very, very good. So now let's do the first one, which is called economic plausibility test. Economic plausibility test. Now, economic plausibility test, it is used to tell us 2 things. One, whether the relationship between the variables is logically defensible. That means if they can remain even as samples or circumstances change. The second one is whether the relationship is making economic sense. That means whether it is in line with what we would generally expect. So what we are going to do is to present it like this. We have the dependent variable. don't know whether I could should have presented. Let me design the table. Let me design the table so that we don't repeat so much. So I have the design. This is dependent. This is independent. This is expected. This is observed. And the comments. So here we are talking of the variable and then relationship. So for the dependent is amount spent. Amount spent. The independent is annual income. So the expected, remember there are three types of relationships. There is what we call the positive. There is the positive relationship. There is a negative relationship or zero relationship. Now positive means they are changing towards the same direction. Negative means they are changing towards opposite. Zero means they have no effect on each other. Now, I want you to tell me, what kind of a relationship would you generally expect, or even in your personal life? What kind of a relationship that exists between the amount of money you spend on entertainment and the amount of income you have? Positive. The more income you have, the higher the chances. Not a must. That's why you're saying the higher the chances. Then, the more money you have as income, the more you are likely to spend. So that is a direct relationship. So we call it direct, meaning it is positive. Eh? Yeah. Then what have we observed? The relationship is observed by this side here. So we have observed a direct relationship, and you can provide evidence. It is positive 0.985761. So now you need to tell us, are they in agreement? What you are expecting and what you have seen, are they in agreement?
Yes.
Good. So if they are in agreement, then you tell us it is economically plausible. It's making sense. It is making sense. Let's come and do the same here on amount spent. Annual income. Not annual income, sorry. It is now household size. What's the second independent variable. The household size. So the household size, what kind of a relationship would you expect? It is positive, so it's a direct relationship. The more you earn in a family, the more you are likely to spend. And what have we observed? We have also observed a direct, direct, which is positive 1.7624 15. So the comment or the conclusion is that there is economically plausible. Economically plausible. So that is what we call the economic plausibility test. Now the next one, they are called goodness of fit tests. Goodness of fit tests. Goodness of fit tests. Now, in the goodness of fit tests, we have 6 of them. We have 6 of them. So the first one is R squared. Now, the question has not given us, but I can, we are already given. Yeah. So we have the first one, R squared. So R squared, we will talk of the value. The value is 0.44. 0.447817, which is supposed to be equal to 44.7817%. Now, the meaning or the interpretation, of that, 44.7817%, 44.187% of amount spent is explained by annual income, and household size. We can add another comment. This is below the recommended level of acceptance. This is below the recommended level of acceptance. Of 60%. 60%. I put 60% because in our notes we normally see you accept a relationship that is 80%. Maybe I should have put in other words, I should have said it is within the region of rejection, because it is below 60%. That's still okay because I'm explaining. But I'm saying you should accept a relationship that is at least 80%. And a relationship that is less than 60%, you should reject. But in between now 60 and 80, you can accept at your own risk. But here in the 80, you can go on with it with a bit of confidence. Yeah. The second goodness of it test is standard error of estimate. Standard error of estimate. Standard error of estimate, SE. Now, in the standard error of estimate, they have not computed, but is normally given as the unexplained variation. Unexplained variation. Unexplained variation. You divide it by residual degrees of freedom. Residual degrees of freedom. Residual degrees of freedom. And then you get the square root. However, remember, when you're interpreting a report, not unless the owner of the report has given you permission to compute, you don't compute. You only interpret what they have. Otherwise, when you compute, they will accuse you of doctoring the reports. But now, for class purposes, the unexplained variation is, if you look at the table of Anova, you can see in the column of SS. In the column of SS, we have 1765. 1765.77. You divide by residual degrees of freedom, which are 17, and then you get the square root of that. Give me the square root. You want to come back to you. What's the answer? Yeah, good. It is the one that is given there, 10.196161. So you can see it up there. There are usually two types of standard errors. There is the standard error of estimate, and then there is the standard error for the slope. You can see another standard error. What table of coefficients? Yes. We will come to that. We will come to that. What I wanted to point out at this point is that there are two standard errors. There is the one that is up there, which is the standard error of estimate. Then the one that is down there is the standard error for the slope. We are coming there in a while. Now this one, there is no much. Now this is what we have called the value. This is what we are calling value. As per this other one. The comment that we can give, the comment that we shall give is the predicted value using the equation. The predicted value using the equation will have an error of an error of plus or minus 10.196161. You have an error of plus or minus 10.196. What that means, if you predict whatever using this equation, and for example, 100, then this means that you can go to a row of 90 and you can go to a high of what? Yeah, so that is the interval. The next one is number 3, F tests. F tests. Now, F tests, it shows us, maybe I needed to mention something else here. We normally say, the smaller the error, the better the equation. But now here, we are not able to say which one is smaller because we don't have another equation. Yeah. Now, F test, there are 3 things that we require. One is the F calculated. Now, F calculated, it is what we call regression. Actually, it's already given. It's already given in the table, so I think I should not bother you so much in the computation. It is, if you look at the Anova, it is 6.89. So I should have said 6.893453. That is the F calculated, and that F calculated is obtained by getting your 716, you divide by 143. Your 716, you divide by 143. That's how you get the 6. 716.0149, you divide. I'm saying 716.0149. You divide by, not by that, not by the 143. You divide, it's the regression mean sum of square, you divide by the residual mean sum of square. So you divide by 103. 103.8688, you can confirm. 8688. 8688. Confirm whether that is so. See, that's true. The second value you require is F critical. F critical. Now, F critical is the value that is given there, 000, 0.006423. 6423. Can you see it?
Yes.
Then the conclusion. The conclusion is that the relationship between amount spent, annual income, and household size, is very significant. is very significant. Since F calculated is greater than F critical, that is 6.893453 is greater than 006423. Just a minute. You know, task and the questions. F test. The next one is R. Number 4 is called the correlation coefficient. Correlation coefficient. Now R, that is the value we are already given. In the table there, that is the one that is going by multiple R, 0.66. 0.66, 9191. When you have it that way, the comment now we normally say the closer to 1, the stronger the relationship. Now this is not very close to 1, so we can write the comment like this. The relationship between amount spent, annual income, and household size. And household size is fairly strong. So we cannot say that it is very strong. So the next test is number 5, standard error of the slope. Standard error of the slope. Now the standard error of the slope is given in the table of coefficients. So value, there are 2 of them. Value to answer annual income. For annual income, the standard error of the slope is 0.31. 0.313508. Then the household size is 1.71. 1.716065.
What is the 558?
That is now for the intercepts, which now we don't interpret. Practically it has no meaning. Yeah, in terms of mathematics, you are able to compute it, but it has no practical interpretation. So the comments. Now we normally say, especially if you, first of all, we say the smaller the error, the better the equation, or the better the relationship. Now that we have 2 of them here, we will say annual income is a better predictor, of the amount spent, than the household size. Since it has a smaller error. since it has a smaller error. Yeah, so that means that if you are given what do you think? Is that true? Practically?
Yes.
That the size of the family is not really very important. What is more important is the amount of money you have. Yeah, that's why you find someone who has one child can afford to spend and even fly and go to a far destination for entertainment. But someone with 5 children may not necessarily spend that money. They can, but not always. Yeah. So I can see, Mark, you are asking the meaning of MS. MS, first of all, is supposed to be MSS, or just MS, but it means mean sum of square. It means mean sum of square. Mean sum of square. Then SS means sum of squares. SS inamaanisha sum of squares. And DF means degrees of freedom. F means degrees of freedom. Okay. So we already have made the comment there.
All these are unexplained.
The 14 that 2 is the explained. The unexplained is the 1765. Then that one, you'll do tunaitanga total. Yeah. Mark, are you okay with those explanations?
Yes, thanks.
Good. Let's move to number 6. Number 6 is the t-test. T-test. Now, t-test is used to show the independence of the independent variables. And we can arrange it. We have the independent variable. Independent variable. We have t calculated. We have plus or minus t critical. And then we have comments. We have comments. Those are the 4 things that we require, or the 3 things that are the independent variable. The independent. No, sorry. We can put it this way. It shows the significance. Let me use the word significance instead of independent. The significance of the independent variable. The significance, how important it is, yeah, in predicting the Y. So the first independent variable is amount spent, not amount spent, is annual income. Annual income, which is our X1. Now the T calculated is the one that you can see in our table, written as T start. T start, which is 0.7311. I think for the interest of my space, I can take to 3 days or just 2 decimals. 0.73. We would be having 1151. We would be having a bigger space. 0.73 1151. Then the critical is the one the table has given as p-value. The p-value. So it's plus or minus 0.4. Am I taking the? Sorry, I've copied wrongly. That 0.73, it is for the intercept, and I'm looking for the annual income. Sorry for that. We are supposed to pick the second one. So the second one is 3.144. 3.144. If you have space, you can write the full of it, but come you are constrained like me. The p-value is 0.00. So plus or minus 0.0059. So you can see it.
Yes.
Okay. So if you have seen it, that is good. So now we need to interpret. We need to interpret. And as you interpret, something like this. Let me remind you.
For the other one, that is the critical. I'm spelling it the same.
F critical ile iko hapo juu, significance F 0.064. That was for F. Sasa tuko kwa T, the table of coefficients. Yeah. Umeona, eh? So I was saying we have three regions. The regions have two boundaries in most cases, or in this test. Now this is the minus. So like now here, this is minus 0.0059. And this is positive 0.0059. That is how the boundaries are. So if you find yourself on this side, on the lower side, we say it is significant. But if you are in between, we say it is insignificant. Insignificant. And if you are on the upper side, we say it is significant. So now, you look at this one. Ukiwekelea kwa hii line or this range, where is it? Is it on the upper side? Is it katikati or on the lower side? On the upper side. So if it's on the upper side, that means it is what? Significant. Significant. Is significant. You cannot ignore it. Something is called significant if you cannot ignore it. We go to the next one, which is household size. Household size. So the household size is the T calculated is 1.027. 1.027. And the critical is 0.3188. Plus or minus 0.3188. So is it significant or insignificant? When you do the same thing there, it is significant. Good. I can see that. Very significant. Significant. That is about the goodness of field tests. The next one is called assumptions. Assumptions. We now test assumptions. There are 6 assumptions. So the first one is linearity. 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 Linearity is tested in 2 ways. One, you plot the graph. When you plot the graph, you check whether it's linear. It's showing a straight line pattern. Now, in our data, we have not been given a graph, so we cannot use that method. The second method is you develop an equation, and you tell us whether the equation is of the linear format, like what we had there. And you can see the equation that we got here comprised in that format. Yeah, it comprised. So that we can, the relationship in this case is linear. The relationship in this case is linear. Since the equation obtained is of the form y is equals to a plus bx. Is of the form y is equals to a plus bx. Okay, number 2. Is collinearity. I don't know whether even we are given, eh? We are not given. I think that's the only assumption we can test. All these others cannot be tested. So I think we shall not write. Maybe what we shall write is just make note. The other 5 assumptions, cannot be tested in this case or in this question. Cannot be tested in this question since data has not been provided. Since data has not been provided. Yeah, so that is how you answer that question. You see now, for the second assumption, which we call zero mean of the error terms, you need to have been given the column of error terms or the mean for the errors. Now it's not given. Because that one says, the second assumption says that the mean of the errors should be 0. So they should have given us either the error terms, we compute the mean, or they should have computed for us the mean, so that we are able to say what we are getting, is it 0? Now that has not been given. The other one, number 3, is that the error terms are homoscedastic. That means they are not depending on the values of x. So for you to judge that, you need the values of the errors, the residual values, and the values of x. You compare. Now, if x is increasing, are the errors also increasing? Or if x is coming down, are the errors coming down or going up? Now we don't have, again, the column of errors. So that one you cannot comment. The fourth assumption is normality distribution, which says that the errors for a normal probability distribution. So what we need to do is have the values of the errors, then we plot a curve. When you plot the curve, you check whether it is taking the normal shape. If it does, then you say they are normal. If not, you will say they are not taking the normal curve. Alternatively, you compute the mean, which should be 0, and you compute the variance, which should be 1. Because any normal or normally distributed data, or data that follows normal probability distribution, should have a mean of 0 and a standard deviation of 1. The other assumption, number 5, is called the independence of the dependent variable. Now, at least we have been given the dependent variables, but that is tested using something we call Durbin-Watson statistic. Now, the Durbin-Watson statistic is not provided here, so we cannot compute. The other one, although that one you can still comment using visual observation, but now you see there are two. There are two, which means if you look at something like the amount spent per week, when you know the first 2 or the first 3, can they help you know the others? Unaona kwanza ni 2,000. The amount, yeah, that is the amount, the amount spent per week. The first one is 2,000.
Which is greater than the second one.
The second one is what? 1,700. The next one is what? So data is autocorrelated if when you know the first 2 or 3, you can tell the others. Can you be able to tell based on that?
Yes. I go up to 300.
Then?
Yes, I can tell. The higher the income.
No. What you are saying is this. The first one is 3. The next one is 5. The next one is 7. And you tell me the next value of what? Using this. 9. The next one? Why? There appears to be a positive what? So in this kind of data, you already need to be given 2, 3, 4 values. Kutoka hapo hizo zingine unajazia. So is it the case with ukiangalia 2,000? Zimeshuka ikafika. So that means there is a difference of what? -3, -3. So if this is the case, if this data is autocorrelated, the next one should be 1,400. The next one should be 1,100. The next one should be 800. Is that what we have? Yes. But that's not a very much acceptable way of testing. The most objective way is Durbin-Watson statistic, which is not provided. The last assumption, which says independence of independent variables, is tested by computing correlation coefficients between the independent variables. And then you check whether any one of them is greater than 0.8. Any one of them is greater than 0.8. Now, in this case, they have not computed the correlation coefficient between the amount spent, not the amount spent, between the annual income and the household size. Yeah, so that's why I've said all the other 5 assumptions cannot be tested using this data. And remember, I told you when you are given a report, you only comment on what the author of the report has presented to you. You don't go computing. They will accuse you of doctoring their report.
For you to compute, mention about me. So how will we appear on this table?
It will just be given the normal way. Either iandikwe in full, mean, ama hivi. See, huwa tunaweka bar on top of whatever you are looking for. If you are looking for the mean of x's, it is written like that. If you are looking for the mean of y's, it is written like that, y bar. Yeah. Kama si if sables, watatupea 1. Yes. Okay. So now, the next concern was, outline 3 factors that might hide or hinder the interpretation of your results. What do you think can make it difficult for you to interpret? Number 1 is what Mike was asking, use of initials whose meanings are not provided. That's a major hindrance in interpreting reports. It's Mark, not Mike. Use of initials whose meanings are not provided. Now, this kind of report is only meant for technocrats, people who are already qualified in that area. But people who are non-technocrats, ukimpelekea hiyo kitu hataelewa what it means. Yeah. And remember, reports are all that to be presented to people who are not qualified in that field. You didn't know that? It is only in academic circle that we present to people who are qualified. And that is only the exam. Like now, when we ukiletoa hii, utaniletea nikumakie. So you are presenting it to me. Me, I'm qualified. But when you go out there, you are an employer. It's not necessarily an accountant. Yes. But they require you to do data and predict and analyze. Yeah. When they prepare a report and they're taking it to the president, to say maybe it's a hard issue. Now that report is prepared by experts on matters that are economists and so on. Now the president is not a RAD expert. When there is an issue in the medical issue, so the report will be prepared by doctors. Yeah. But it's the president to interpret. It's not a medic. Yes. And many other cases, many other. That's why I'm saying that the report is normally done for people who are not experts. That's why we are hired. Your employer has hired you because what you do for them, they cannot be able to do for themselves. Yeah. Otherwise, if they can, they will not need you. Ni kama tu kama ungeelewa MA na ukipita saa hii, I told you the other day, ukipita MA hautakuwa na hoja yangu. That's the practical. Lakini kama hujapita, you still need me. Yeah. But the moment sasa umeelewa MA na umepita, you don't need me. Yeah. Sure. So any presentation that I'm making to people who are not qualified in that. Good. Another reason is non-disclosure of all the relevant information. Non-disclosure of all the relevant information. Non-disclosure of all the relevant information. You see, like I've just said, we cannot now test the assumptions. And assumptions are very, very critical. But these fellows have deliberately chosen to hide that data. Because that data is somewhere and it was used in arriving at some of the values that we have. But they have, remember the sheet that we normally do in 8 or 11 columns. So that sheet is there. So why didn't they give us all the columns? They only gave us 3 columns. Only give us 3 columns. We need to. Okay. And when you see some people disclosing or hiding some information, it could be an indicator they want to take advantage. Otherwise, if they were to give you full dose of the information, you may make a different decision. You not all, but relevant. Yes. Yeah, like yourself, I know you're in the bank, and banks will not work on what we call hidden. Hidden what? Like when I come to borrow money from your bank, you people are applying for 100,000. Na kwa form, now all the negotiations include 100. Tunaongelea about 100. Lakini siku ya kupewa, am I given the 100? Sasa hiyo ndio ninaambiwa, hey, sasa kuna kitu kanaitwa insurance. Kuna kitu kanaitwa processing fee. So you find I might go home with 97 or even 90. Yes. Yeah. That's why na most likely kama sasa ningeambiwa hapo to fit I would have changed my mind. Yes, not a math, but I would have changed most likely. So because the bank does not want me to change, they first of all want to get hold of me. That's why the information will never be fully provided. And it's not only in banks. Anywhere there is a relationship, that is to be formed, people will rarely disclose all the relevant, either by design or by default. By default is like now what happens in marriages, whereby when you are coming to me, you cannot know me fully because hujaishi na mimi ndio kabisa. Lakini sasa wakati tumeanza kuishi pamoja, that is now when you now start seeing characters you never saw, but already ushaingia. Yeah. By design is where ninajua kama sasa hii I know there are these charges. Even a school like this one, tulikuwa nayo although ilitolewa the installment fee. Unaambiwa school fees ni 9,000. Lakini hawakuambii ukilipa pole itaongezeka na 1 kueteni. So wewe unalipa pole wakati unafikiria sasa total umelipa 9 unaambiwa hapana una balance ya sasa maneno inaanza. Sasa that is by design. Hao watu walijua hivyo lakini hawakuambia. Kama ungeambiwa ni 10, maybe you would have changed your decision, which now could be ukatae kuingia shule ama badala ya kulipa na installment utafute pesa ulipe yote pamoja nayo. Yes, that's also a decision you could have made. Yeah. Instead of ulipe pole uchajiwe 1,000 maybe in a period of 1 or 2 months, afadhali ungeenda ulete yote na wewe ujiondolee hii. Yes. So that is what I mean by the decision could have been different. The other one is lack of required statistical knowledge. Lack of required statistical knowledge. So that means I think it's just what I had said, and that reports are meant for people who are not qualified in that area. So ukipea mtu hajui hii, then you find that they cannot interpret. So are we good with that? Naona time imeisha to start another question. But let me see whether there is a question that can add 1 or 2 items to that. Sina. I don't know. I was wondering why September 15. Yeah, hii swali ya it was tested in September 2015. I just wanted to show you how we tested so the question of September 2015 question question 4C. So there is what we call correlation coefficients matrix. So that is the matrix, the correlation coefficients matrix. Sasa hiyo ndio nimekuambia, it is used to test the independence of the independent variables. So kwa hii swali sasa walikuwa wamepeana. So now here you can comment about it.
Dividing the independence of parent variable.
Kwanza copy mpaka hapo so that you make the comment. I'm only commenting about this, not the whole question. Yeah. So the comment, the simple comment that we can make is this. There is no collinearity. There is no collinearity among the three independent variables. Among the three independent variables. Among the three independent variables. In the above case, since none of them has a correlation coefficient. None of them has a correlation coefficient greater than 0.8. Greater than 0.8. So we are looking at this one. How much? So the correlation coefficient between labor and overheads, actually we should focus more on not even that way. Let me narrow down to, let me remove this one there. Because we are focusing on the ones amongst them. These three. That's the focus. Those three. Now this is the correlation between material and labor. This is the correlation between orders and labor. And this is the correlation between material and orders. You see, none of them is closer to 0.8. So that means they are not influencing each other. Yeah, that's how it's interpreted. But come in one of them was something like now this one 0.9. That was 0.9. Then you take that material and orders are collinear, meaning they are influencing each other. To influence each other is where what I am doing is what you shall also do. You are not able to act independently.
You're depending on the orders.
Material and orders, one of them is following the other one. Okay. Yes. That's what we call dependence. But if we are independent, kila mtu anafuata njia yake na kila mtu anasema ati anafikiria. But if one of us is not independent, unangoja mwenzako aongee ndio na wewe uongee hivyo.
That's what if that one is 0.8.
Kama ingekuwa more than 0.8. Yes. So you're an example.
0.8.
Those are standards that are already developed. Yes, those are standards that are already developed in the interpretations. Ni kama tu ukienda hospitali, tuseme wanapima kitu kama blood pressure. No, it's called blood pressure. Hii wanawekanga hapa. Body pressure, whatever it is. Ile tunasikianga ni 120, you can 120. So already sasa how people they know, they have done research na wakajua if the pressure is between 100 and 120 huyo mtu ako sawa. But ukipata less than 100 or more than 120 kuna shida. Yeah. So those are standards that are developed after very many objective researches. Good. Any other question there? So we then call it a day at that point and pick up from there in the next lesson.
Tomorrow is our last now.
I suggest you meet on Saturday.
Yeah, it is interesting.
We meet on Saturday, not tomorrow.
Yes.
Saturday, the usual time.